the robots that Tesla produce are going to be so real that you will have to poke them. This is what Musk said. So it's like the AI is going to have a body, right? So the humanoid robots are coming into picture. Tesla announced Optimus 3 and Figure AI announced O3. So Figure AI is another company that is a pure humanoid robotics company. So we can visualize Figure AI as if Boston Dynamics and OpenAI came into picture. So the OG mechanics and robotics company Boston AI and the OG AI company OpenAI has come into, you know, a combination to produce something. So I mean, Figure AI is not exactly a combination of this, but we can visualize Figure AI to be that kind of a company, right? So Figure AI is also backed by top players like Microsoft and Nvidia, and works a lot in humanoid robots. Now, what the hell are these humanoid robots, the Optimus and the Figure AI O3? So we can imagine humanoid robots as if they can do all the human-like tasks. For example, imagine them in doing hospitality work. Imagine them in cracking an egg, cooking something. So this is what a humanoid robot can do. I mean, they can end to end execute a task with human like precision, right? So they operate at very high frequency, 200 hertz of frequency, and they use a certain model that are known as vision language action models. I mean, they don't only operate on an AI system that is based on a large language model, a tokenization based model. They operate on a different AI system. For example, Figure AI uses Helix AI, which is their own proprietary AI system, and internally they use something known as vision language action. So what the hell is vision language action? So vision language action is nothing but you can imagine them as another foundational model for robotics where the input is not text, the input is multi-model. The input can be commands, right? And the input can be set of actions, the input can be images. Now what is the output? The output is the set of actions that a robot has to take, right? So this is what vision language model is based on. So vision language model is the core brain behind the AI system that these humanoid robots use. And the challenges with vision language action model is that they don't operate like LLMs. They scaling laws do not apply to them just like they apply on LLMs. And the challenge is that they need precision. For example, every second they need to decide or they need to inference themselves for 200 actions to produce human like reflexes, to produce human like precision in anything, right? So it's like if you want to make the robot feel so real, you need to, you need to embody. So they are also known as embodied AI. So you need to embody reflexes, right? And every 5 seconds they have to see or process a different vision. So when they have to see a different vision, that means they're going to inference or query their own model, right? So that also means that the model cannot be hosted somewhere on the cloud. That also means that the model has to come and sit on the machine that the humanoid robot is running on, right? So because they have to query them, I mean, they have to query them at least 200 times a second, right? So, which simply means that inferencing should have very, very low latency and very high precision, right? So, we cannot operate on a large language model or on a cloud LLM based model where our model is sitting on a cloud and we are just, trying to make a network connection with the cloud and then querying the model, right? So, we need to have them locally. So, that also means that we need to drastically focus on building robotics chips, robotics hardware that that can do massive matrix multiplication so that we can fulfill their input requirements. So this is what has been going on in humanoid robotics. So cool things to learn for engineers are the idea of vision language action models. So we also call them VLA models. So we have already seen LLMs and how we can compare LLMs to these vision language action models, and the way scaling laws apply on LLMs, do they also apply on a model that takes multi-model input, set of images, a set of commands, and a set of actions, and produces high frequency motor action. So which is basically tells the robot to do a certain action, right? So that's how we call them, that they produce a set of action. So they are not doing next token prediction, they are doing next action prediction. And in 1 minute, the number of actions that they have to produce to have human like precision is huge. And in 1 minute, the number of times that they have to query and reprocess and reprocess process and reprocess their current environment is massive, is humongous. Now when we talk about scaling laws and compare them to LLMs, so the problem is LLMs had the data that LLMs consumed was internet scale data, and it was cheap. We could synthetically generate it. We cannot generate synthetically robotic actions, robotic context and robot interactions, right? So we don't have that data available at the scale that we had at for LLMs, and it's going to be very expensive to generate them synthetically. And we cannot have a simulation environment realistically where we can generate trillions of tokens of robotic interactions, right? Just like we could maybe for large language models. So scaling laws won't apply the way they used to apply on large language models. Then the memory wall basically is another argument or another let's say paradigm that critics keep on arguing, like if we have to inference them, at every few milliseconds, how will we handle the matrix multiplication locally, and how will we host them locally on the machine? Are we ready for the hardware? Do we have that robotic specific computing hardware that can do massive matrix multiplication to fulfill this, human like actions and human like reflexes from a humanoid robot? Yeah. So the sentiment around both of these humanoid robots is filled with fear and curiosity and wonder. We don't really know what's going to happen when AI gets a body. And Elon Musk also keeps on claiming that Tesla Optimus is going to be a robot, which is manufactured and deployed in the same factory. So what it really means is that a factory that is going to manufacture Optimus will also deploy or use Optimus to build more Optimus, right? So I think Musk has gone crazy with his vision on Optimus and humanoid robots. Let's see what's about to come in the whole humanoid robotics and how the AI systems evolve with vision language action models. Cheers.